Okay, 15. More derivatives. Z prime is bottom. Because it's a quotient, I have to use a quotient rule. Times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. And then on these we just simplify what we can easily, which is distribute and combine like terms. So I'm going to do this all in one. Right? So that's 15t minus 15t. Okay, let's do it like this. Plus 6 minus 15t. Oops. Minus 5. Remember, this negative distributes all over 5t plus 2 squared. So that just becomes 1 over 5t plus 2 squared. That's C prime. Okay, number 17. F of t equals 2t e to the t minus, now the 1 over square root of t, I'm going to go ahead and change to t to the negative 1/2 power, because I know I need to do that to take the derivative of roots. So then f prime of t would be, that's a product first, times derivative of the second, plus a second, times the derivative of the first, minus a negative 1/2 t to the negative 3/2. So that becomes 2t e to the t plus 2e to the t plus 1 over 2t to the 3/2. Okay, so there's f prime of t on that guy. Okay, so basically we're just, obviously I'm taking derivatives fast, and that's the sooner, that's where you need to be, is just taking derivatives of, 5t plus 2 and 3t plus 1 and, t to the 1/2, and you'll get there as you keep practicing and doing more and more. Number 18. F of x equals x squared plus 3 over x, so f prime of x, it's a quotient, so it's the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared. So simplifying, we get 2x squared minus x squared minus 3 all over x squared. So that becomes x squared minus 3 over x squared. And I know that none of you would try to cancel that x squared, because that has to divide into both. 21. F prime of z is the bottom. So I'm going to write it like z to the 1/2 times the derivative of the top, 2z minus the top, z squared plus 1 times the derivative of the bottom, 1/2 z to the negative 1/2 all over the bottom squared, z. Okay, doesn't look that pretty, but let's go ahead and multiply it out. So we get 2z to the 3/2, right? Add the exponents, minus, if I distribute this, I'm going to add the exponents. So I'll get 1/2 z to the 2 minus 1/2 is 3/2 minus 1/2 z to the negative 1/2 all over z. And we call it there. We could, get rid of that negative over here and so forth, but we'll leave it at that for this problem here. Okay. All right, 21. We're on what? 23. 23 is another quotient rule. H prime of r, I'm looking up here, is the bottom times the derivative of the top minus the top, times the derivative of the bottom all over the bottom squared. So that'd be what? 4r squared plus 2r minus 2r squared over 2r plus 1 squared, which is 2r squared plus 2r all over 2r plus 1 squared. So there's your h prime of r. Okay. Alright, doesn't matter which variables we use, r's, x's, t's, they are all the same. 24. This guy. Okay, I gave you a lot so that you would get lots of practice. F prime of z is the bottom times the derivative of the top. Uh-oh. Let me move this and do this somewhere else. 24. I've got f prime of z is the bottom. Oops. 5z squared plus 7z times the derivative of the top minus the top. 3z squared times the derivative of the bottom. 10z plus 7 all over the bottom squared. Alright, so simplifying a little bit, that's going to be 30z to the third plus 42z squared minus 30z to the third minus 21z squared all over 5z squared plus 7z squared. Combine like terms. 30 minus, oh, those cancel. 42 minus 21 is going to be 21z squared over 5z squared plus 7z squared. As long as I don't make any mistakes by doing this quickly, we should be good. And last one on here is 27. X squared plus 3x plus 2 all over x plus 1. Let me double check. Yep. Okay, f prime, again it's a quotient rule, is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom squared, and multiply this out, we get 2x squared plus 3x plus 2x plus 3 minus x squared minus 3x minus 2 all over x plus 1 squared, which gives us an x squared. 5 minus 3 is 2x. 3 minus 2 is 1 all over x plus 1 squared. And if you notice, the numerator is x plus 1 squared, is it not? Over x plus 1 squared. Something's not right here, because this should not be equal, because this should not be 1, because that's not 1. So let's see what we got here. Oh, maybe so. Let's see, we got 1. So let's go ahead and see. Here you can see why I'm wondering if this is right or not, because how could all of this, the derivative, just be 1? Well, if we go back up here and simplify this, this is x plus 1 times x plus 2 all over x plus 1. And then those cancel, so then the derivative of x plus 2 is just 1. So that is right. Now, had I noticed this at the beginning, that would have been a whole lot easier going from there right down to there. But I didn't see that, so I did it the old way, and I still got, or the long way, and I still got the right answer, so we're good on that. All right, next time.